So we have a solid grip on the fact that electrons, protons, and neutrons make up an atom. And we have understood that protons and neutrons are at the center, while the electrons, they exist around. Now the question of this exist around is what we are trying to answer. So basically we are trying to look at, are this electron moving around in a very random manner in a very random space? And the answer is a simple no. Now the question is, if it's a no, then how exactly are they moving? Around the nucleus, that is. Well, electrons might look that they're moving in a random manner, but within a specific region. We can think of this region as a fuzzy cloud surrounding the nucleus. Let me put it in this way. Guys, all of this is oversimplified, so don't take it too literally. If this is a space wherein the neutron exists, it's a proton and the neutron exist, we can imagine that electrons are moving around in this space. Okay, covering that. So within, say, we can imagine that they're moving around on the surface. Okay, got it? So if I zoom in, you can see that this it's a empty sphere, and that's how it would be. So it's a spherical shape, but within the surface, right? On the surface is where the electrons are moving around. You can imagine that. And the perspective. Okay, guys. So that's the sphere. If I go inside, it's hollow. Okay. So we can imagine it to be so. Right? Now, do they have the name? Have we named the space something? This fuzzy cloud, does it have a name? And yes, that is your orbital. We have already seen this word, orbitals. Many orbitals combine to form subshells. Now, are there different shapes within which this orbital and subshell exist? Are there different shapes? Or is everything sphere? To begin with, yes, we have spherical shape orbitals and subshells. And other shape that I want to mention is dumbbell shape. And many dumbbell shape, like this three pair, which is along x, y, and z axis, they form your subshell. Okay, guys. So each of this is an orbital, and they combine to form your subshell. So we have many different shapes, actually. Not a lot, but few are there. And they are SPDF. We have 4 different subshells. They are of different shape. S subshell is spherical in nature. P subshell has dumbbell shaped structure. D is more complex. F is even more complex. You don't have to remember that. You don't have to remember what shape are those, but knowing that helps. And you can web search the D and F's, how they are structured and everything. It's kind of complex. So I'm not able to show it over here. But yeah, we have 4 different shapes. Now, for a given subshell, I mentioned that a subshell is made up of number of orbitals, is it not? Right, many orbitals combine to form subshell. So S subshell is made up of 1 orbital, P is made up of 3, D is made up of 5, and F is made up of 7. That's something that you have to remember. Everything else you guys can read it and have it in mind. So a subshell, which is S subshell, has 1 orbital, is what you have to remember. P has 3, D has 5, and F has 7. Right, here you saw P, this is a P subshell, and it has 1, 2, and 3 pair of orbitals. As simple as that. More complex structure and so on and so forth is what other D and F are made up of. It's a space, it's a region basically. And that space and a region, it takes up a special shape, and that's what I'm oversimplifying it. Okay guys, now do all orbitals accommodate the same number of electrons? And the answer is yes. Regardless of what orbital it is SPDF, they accommodate 2 at a time. So basically, let me start with P, right? This entire thing is a subshell and this single thing is an orbital. And this orbital accommodates 2 electron. And since P has 3 of this structure, 1, 2, this was the first one, this is the second one, and this is the third one. And so we have them 2 plus 2 plus 2, them allowing 6 electrons to exist within that space. When it comes to our spherical shape, it allows 2 electrons as a whole. Okay, so spherical structure allows 2, while this P structure subshell allows 6 electrons basically. D, take a guess, how much does it allow? So do all orbitals accommodate same number of electrons? Answer is yes. Do all subshell accommodate the same number of electrons? Think about it, we just discussed that. Let your brain run. And the answer is no. S accommodates 2, the spherical structure accommodates 2, P accommodates 6 that we just saw, right? Take a pause and think about it. Okay. D accommodates 10 and F accommodates 14, right? And this is related to this set of values 1, 3, 5, 7. So if you multiply this with 2, you will get this set of numbers. Where is that? Here. 2, 6, 10, 14. This combined with this. Okay, yes. To end with image of a subshell and orbital, right? So S is spherical in nature, P is dumbbell in nature, P is dumbbell in nature, D is flower in nature. Okay, let me just show that. That's your P. That's your S.